Hey guys, good morning. Can you please confirm the chat? Am I audible to you? The screen is visible, right? अन्ना क्या? चलो. So yesterday I have shared some questions, right? That are the recent interview questions yesterday. One of your senior student. The first question is metrics and classifications. Metrics and classification. You are able to do this, right? Metrics and classification. Say yes or no. We covered this in class. I hope you are good at metrics and classification. You are able to say that. Next, if you are not able to say that, you will not get job, because that we already covered in the class. What is the second question? Second question is YOLO. YOLO V8. So this is, I can easily say, this is many trainers will not cover, because YOLO is not a textbook algorithm. It is a kind of a real-time scenario, but we will cover that real-time scenario YOLO algorithms. It is yet to covered. But I can proudly say that this I will cover as a real-time use case. YOLO is not a textbook algorithm. What is this? Listening songs. कौन सा गाना? बोल, I will also play. Huh? Everyone listen in the class. That is very bad. Bad behavior. A two covered, that is. Okay, that is a real-time algorithm. Real-time this is. This is you look only once. Okay, that is called, full form is what? You look only once. That is called YOLO. Third question is finding the prime number. Finding the prime number. And I hope my students are good at Python and they can easily do this prime number concept, right? That is finding the prime number. I already shared a book of 140 Python programs, right? If you solve these 140 programs, you will crack the Python interview. No doubt in that. And that out of 140, I can easily say that 70 questions will be done in the class. If you want, you can see that 70 questions will be done in the class. First question is hello Python. Everyone can do that is addition, division operation, area of triangle. This kind of operations be done many times. If you know the formula, you can easily do that. Tax payment, tip payment, area of the triangle, that everything. So and swap two numbers. It is a assignment question only. Generate a random number. You know how to generate the random number. Kilometer miles. This is also assignment question only. Celsius to Fahrenheit assignment question only. Display the calendar, like import time package. What will be there? Calendar package is there. And quadratic equation. This kind of equations are tricky if you know only the solution. How can you find anything quadratic equation? What is the formula? Minus b plus or minus root over b square minus 4ac by 2. If you know that, then only you can solve it. Otherwise, if you're not able to solve that. So this, and next, swap two variable without temp variable, that you already done. That is positive, negative, 0. We checked it. Odd and even we have done is leap year is very famous question in the hacker rank. If you go that that you can easily find that. A prime number. Okay. That means if you practice this 140 questions, prime number between interval 1 to 10, you can easily crack that interview. Prime number, factorial number, वो बोलता क्या मैडम का रिवर्स करने तो मैडम आता. Palindrome, Armstrong numbers, this kind of things very common questions. Finding the greatest number, how many words are repeated, in the what is the minimum length of word, what is the maximum length of word. These are the very frequent questions, man, that you can easily achieve. Multiplication table also is the interview question, assignment question only. Fibonacci series is also very famous question. Armstrong number, famous question. If you solve this, you can easily qualify the Python interview without doubt. Okay. And we done amount of time in the Python class, right? 30 days we have learned the Python thing. So never ever say that I didn't crack the Python. Okay. You should crack the Python interview. What is the next question? The fourth question is, given the filter 3 sliding, that is the convolution neural network, CNN, that is the deep learning algorithm. That is also yet to covered. CNN, RNN, ANN, and fifth one is what? OpenCV. OpenCV. That is also yet to covered. That's the deep learning questions. And difference between ML and DL, you can easily say that ML, DL versus NLP, you can easily say that, right? I hope that is a good. Okay, this question is very easy for you. Create a file and edit the file. File handling session. How to read and write the files. Read and write the file. That you are good. That is also we covered in the class. That's why I said it is good. Class and object. That is yet to covered. That we are tomorrow we will do that. Class and object yet to cover, that is. And this is also very easy. You can create a CSV file with 2 columns and 5 rows. If I give the list, you can do that. If I give dictionary, you can do that. We learn that, right? That is also good. And the 10th one is, it is the inserted value. You already done median imputation and all these things, right? Median imputation, outlier things, that is the inserted value. That also we done. That is also you are good. And what is that next? Text file contents. What is the text file content? Annotation of images. Annotation of images. This is some file type they are asking. This is a tricky question. The answer is called XML sheets. .xml file. That is answer is. That is XML. That is also we need to cover, yet to cover, that is. Because image or deep learning, right? That is also yet to cover, you can say that. And what is the next question? Train and test, that is very easy for you. Train versus test data versus, that is easy for you. So that is also, you are also good. And what is the 13th question? List and versus tuple also easy for you. That is also we done in the class. Tuple you only done write up, correct? That is, next question is what? Prior experience with real-time projects. So my students can easily say that yes, because we will do all real-time projects only as a per resume. That at the end of thing. And supervised, unsupervised learning, all ML algorithms, you know that. That is we already done. All the ML algorithms. And what is that precision recall also? So much discussion we have done on the precision and recall, correct? This is also your good. This is also good. When this guy sent the questions, I felt very happy because this guy is very happy. He told me that whatever you have covered in the class, that everything is done. Everything is there. Now you can just count that how many good are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 16 questions, you are in the position now to do 11 questions should be answered now. If I conduct the same exam to you, each and every batch in the student, because everything we covered in the class. And at the end of our class course, 16 out of 16 you need to say at the end of the course. Now in middle of the course only we done almost 11 out of 16. If you are not able to say 11, simply you will not get job. Because I covered in the class. I given the assignments. I asked to write up many stories, and you are not done anything. You will not able to crack the interview. So this is a real time scenario. Are you able to say 11 answers or not? Question yourself. Next question. If you are not able to say, discuss among yourself. Why I am not able to say? Is sir is not covered? First question. Yes, sir is covered. What is the next question? Even though sir is covered, why I am not able to say? Tell me. Bolo. What is the answer? Because I didn't prepare well. ఓకే. తెలుగులో ఒక సామెత ఉంటది. ఏంటి శ్రీకాంత్ సామెత? గుర్రాన్ని చెరువు దాకా తీసుకుపోగలుగుతాం. తర్వాత ఏంటి? అంతే సేమ్. My job is I need to provide the knowledge. Okay. Whether you after that whether you learn or not learn, that is your wish. Okay. I can take that horse to near the river, but I can't give the water like this, no? That is very good, ma. Very good. That is good questions. And these are very, very basic questions. My students easily can crack this. The very, very basic questions. This is all. And tomorrow have a class is there, ma? Next thing is called tomorrow have a class is there. No, 9 to 1, not 1. Tomorrow Naresh Shet is not giving holiday. So as usual. As usual. 9 to 10:30, but we'll go to till 9 to 11. And tomorrow, today we'll close that ML algorithms, that important one. And next week, from starting Friday to till all next 10 days, next 10 days is completely with Python only. Python ML code. Python ML code, that is. So tomorrow we'll start with class object creation, that everything. Class object, create your own packages, that everything, that is. And then Friday, Saturday is pakka 9 to 4, 9 to 1. 9 to 1, 9 to 1. 9 to 1. Saturday pakka 9 to 1. We will do regression. We'll do regression. And if time permits, we will do that API creation also. And Sunday also 9 to 1. By Saturday, Sunday 9 to 1 classes, you will complete maximum of creating application. Testing in Postman. That everything I will teach that. That is. So the next 3 days is very, very important. And Monday onwards, Monday we will do classification with Python, classification models using Python. And next that week, then cluster with Python, cluster with Python. Maybe we'll start from 5th onwards, deep learning. Okay. Because again, the same story. In the what are the algorithms are left now? Only SVM is left and bagging and boosting is left. Bagging and boosting is left. Okay. These are the 2 algorithms are left. That is main algorithms. So that we can finish. So tomorrow as usual class. Tomorrow as usual. That is. And tomorrow onwards we'll start that Python run. Chalo, next. Ensemble methods. Ensemble methods. Ensemble methods. And one more thing is take that Azure account for students only, ma. Don't take that credit card details, wala. That is coming only 1 month, na? Then don't take it. What do you use for 1 month? స్టూడెంట్ ఐడి ఉంది కానీ అది వస్తలేదంటే కాలేజ్ డేటాబేస్లో లేదని అర్థం. అజూర్ డేటాబేస్లో కాలేజ్ ఉంది కానీ అజూర్ వాళ్ళు ఉంటారు కదా, అజూర్ మైక్రోసాఫ్ట్ కాలేజ్ పేరు ఉంది కానీ వర్క్ అవుతలేదు. ఏమొస్తుంది? నాట్ ఎలిజిబుల్. నాట్ ఎలిజిబుల్ అంటే ఆ ఈమెయిల్ ఐడి ఏమైనా రాంగ్ ఉండొచ్చు, చెక్ చేయ ఒకసారి. మెయిల్ ఓపెన్లో ఉంది. మెయిల్కి ఏమైనా లింక్ వచ్చిందా? అయినా కానీ నాట్ ఎలిజిబుల్ వచ్చిందా? దట్ ఈస్ టేక్ దట్ అజూర్ ఫర్ స్టూడెంట్స్. ఆస్క్ యువర్ ఫ్రెండ్స్ అండ్ ఫ్యామిలీ. నో till now how many are taken the account? Raise your hands. So students are normal. Who is which college? CVR college. So you are studying in CVR college. Your friend is there. Help your friends, no, take other numbers, email IDs. Friends ka friends. Like that. Because email ID ko kya hota? Kuch nahi hota na. Anyhow they are not using. Like that chain process. 1 year it will come. It is very very best, no? 1 year, that is. Ask your friends. Like that only. Utkarsh, how you have taken Utkarsh? Student account or normal account? Normal. Normal is only 1 month, no? Don't take normal 1 month. Wait for that inquiry for that students. Anyhow, some link will be available, no? Some link. Chain process. Not possible. Why? No. CVR college is working, no? Ask that Venki. That is the link I am saying. Are you getting? Request for Venki. अरे वेंकी वो फ्रेंड को पूछो ना, एक ईमेल आईडी चाहिए. Simple. Request करो like that. Go ahead, inquire your family. Anyone, somebody will study in JNTU or CBIT or Vasavi or Srinidhi or Gokaraju Rangaraju or CVR College, MGIT, Mallareddy. Anyone, somebody will. Mallareddy, so many people are there in Mallareddy. NIT, IIT, some people will there, no? Family. You'll get 1 year, no? 1 year means huge time, that is. So your college not autonomous. Get like that. No, ma, student is student only, no problem for students. Sabita, I am taking so many student accounts. Okay. How I am learning then? How you are thinking? I am creating every time new email ID, new credit card. No, student account. Have many students are there. I'll just ask them. Then they will give the ID. I am practicing that like kind of thing. So that is. Take that. Chalo. What is the English meaning of ensemble? What is the English meaning of ensemble? Google it. English meaning of ensemble. Group of. Very good. Group of items. Group of items. Now ensemble algorithms. Ensemble methods or algorithms. Then group of bolo. Ensemble means group of items. Ensemble methods algorithm is group of क्या होता? क्या होता? Algorithms होता. Group of that means group of algorithms. The idea is like this. Suppose a data has 1,000 observations are there. Am I audible to you, ma? Can you please confirm the chat? Yeah. 1,000 observations are there. Now you want to develop a, listen very carefully. Now you want develop an ML algorithm. Generally, what you will develop? You will develop 3-4 algorithms, no? You know that logistic regression is there. You will apply logistic regression on 1,000 observations. Similarly, you will apply decision tree on 1,000 observations. And then you will apply Navi bias on 1,000 observations. Individually. Suppose 3 algorithms you applied it, 1,000 observations. Suppose one more algorithm will take KNN on 1,000 observations. In that, based on metrics, precision, recall, ROC, curve, you will pick the best model. Now, ensemble means it will follow like this. What happen? We'll divide 1,000 observations into, suppose, 4 parts. How many parts? 4 parts. When you divide, each part has how many observations now? How many observations each part? Bolo. 1,000 by 4 kitna rahe? I already written 2. You are not saying 250. Wow. 250. Each part has 250 observations. Each part has 250 observations. That is nothing but part 1 and part 2 and part 3 and part 4. We'll divide 1,000 observations into 4 parts. Each part has 250 observations. That means part 1, part 2, part 3, part 4. Now, part 1 is developed. Okay. Now, one algorithm, logistic regression apply on part 1. Logistic regression apply on part 1. Next, similarly, decision tree apply on part 2. KNN apply on part 3. Now, Navi bias apply on part 4. Now, 4 algorithms we created on the same data set, but different observations. Understand above and below again. Here 1,000 observation is there. You are applying the logistic regression on 1,000, decision tree on 1,000, Navi bias on 1,000, KNN on 1,000. Finally, what you will pick? You will pick the only one model will come output. Only one model. But this is what happened. You divided 1,000 into 4 parts. That means each part is how many? 250. Part 1, part 2, part 3, part 4. Each part will develop by one another model. So 4 models will apply on the 4 parts. Tomorrow a new test sample you want to test. This new test sample will pass through all 4 models. Will pass through all 4 models because 4 models are developed, no? 4 models are developed on the same data set but different observations. It is a committee. Think like it is a committee. Now, how many committee members are there? 4 members are there. Now, this new test sample will pass through the all 4 models. Now, every model will give one answer. And the final answer is, tell me, committee, how can you finalize the final answer committee? There are 4 members or committee people are there. How can you get the final answer? Majority, na? So majority voting is the answer. Final answer is equal to majority voting. This is called ensemble method. This is called ensemble method. Now I'll represent in the diagram way. Let's understand the diagram now. Understand the diagram. So this is the data, 1000 observations. And this data you will divide into, suppose 4 parts. This is one part. And this is the another part. And this is the third part. Now this is P1 total data. This is what happened now. Total data D. Total data D. And this is nothing but a D1. This is a D2. This is a D2. And this is D3. And this is D4. D4. Now this D1 will develop by one algorithm. This will develop by one algorithm. Which algorithm? Suppose a logistic regression. One model. Similarly, this guy also develop one model. And here also develop one model. And here also develop one model. So same thing here. Come like this, one model, and one model. I am not good at drawings. Okay, excuse me. And this is what happened now. Logistic regression. This is a decision tree. And this is what happened. Navi Bayes. And this is KNN. A new test sample will pass here. New test sample will pass here. And new test sample will pass here. New test sample will pass here. Same test sample. Same will pass. New test sample. And new test sample. Same will pass. Now everyone will give one output now. This will give one output. This will give one output. This will give one output. And this will give output. And this all combined, what is the majority voting? And that is the final answer. That is the final answer. Understood now? Data divided how many parts? 4 parts. And the 4 parts, each part will apply on the different algorithm. And you can, whenever new data will pass, you will take all the results and take the majority voting. So I'll just now share that. Same, no? Then only you will get the majority, no? So think like real-time scenario. A sitting judge is there in Supreme Court. How many judges will be there in one bench? 3 or 4 members will there, na? Same problem will take, then they will discuss and they will provide the answer. That's why Supreme Court is a huge thing. Because there is a committee is there. Committee of judges are there. So they will discuss and they will provide the answer. Every judge will sit on the same bench and everyone will talk, not take the different questions, right? Same question only Same answer. They will discuss and they will provide the answer. Same thing here also. So that is called ensemble. You see here. So many pages are there. You need to study, no? 49, 53, 55. This one. This diagram is good, better than my diagram. Okay. So data D1, D2, DK, M1, M2, MK. New tuple, combine the words, prediction. Simple. Now tell me what is the ensemble methods? Tell me. Yeah, divide data into parts. Then each part is developed by one model, and then a new test data will pass through the all the models. Then the final outcome is the majority of the voting. Tell me again. I got new laptop yesterday. I returned that laptop. Party. Yesterday I went to office. After 1 month I got the headache. I didn't sleep the whole night. Yeah, still I have headache is there, but I should continue the class now. I have taken 2 tablets in 2 hour duration. That is very bad, I know. But so much headache is there yesterday. That is. So this is all bakwas things. Why I am getting headache? I'm just thinking after a long time I went to office. So many people are there in IT people in Hyderabad. So many people are there. No place in metro, nothing. All these things. Very bad that is. So many people are there. Very good. Now, what is the questions are raised for on this? Tell me. Tell me your questions. How to find the majority? You are saying yes, I am saying no. Your friend is saying yes. What is the final answer? Take odd number, no? That is take odd number, no? That is not valid question. Tell me other question. One important question is there in that. Tell me that. Yeah. Huh? Bolo Soro. Tell me that only. Categorical data means majority voting. Numerical data means? He will say. Tell me. Then why you are asking the question? That is also not valid question. Understood? We already discussed. Categorical means what? Majority voting. Numerical means mean. There's no doubt. Whenever multiple things is there. Ask me valid question. Ask me valid question. There's important question is there in that. And the question is first 2 lines, first 3 lines. Without? Without event observation, normal model. Na? Till yesterday we learned that only. That is also not valid question. You don't want divide it, don't divide it. Tell me another question. You can divide into equal parts. You want divide into some ratio. That is your wish. Again, same. You are come to very slowly. Tell me the next. The question is, what is the question? How to divide the data? That is a valid question. If you divide like, who is your favorite hero? Means Shah Rukh Khan. All Shah Rukh Khan fans are separately. All Salman Khan fans are separately. Then क्या होता? Model will confuse होता ना? That is the problem. How to divide the data is the question. The next is thing what? The next thing is what? How to divide the data. So in ensemble methods are divided into 2 parts. divided into two parts. One is bagging, another one is boosting. So let's come to the bagging now. Let's come to the bagging. So bagging nothing but B plus aggregating, that is called bagging. B plus aggregation. Generally, that is the B plus aggregation. Here B is nothing but bootstrap aggregation. Bootstrap aggregation, very, very important interview question. Bagging follows a bootstrap aggregation. That means how to divide the data is the question, a valid question. How to divide the data. How to divide the data. Based on that, we divided a technique is called bagging. Bagging is nothing but bootstrap aggregation. So bootstrap aggregation. How to divide the data? Bootstrap aggregation. Now tell me, what do you mean by bootstrap aggregation? Okay, Google it and explain me. What do you mean by bootstrap aggregation? What do you mean by bootstrap aggregation? Randomly, okay. That's all. Tell me, enough that is. Huh? Random sampling. That is okay. That is why to use, that is overfitting, how to use. But what is the meaning of this? Suppose you have a bag is there, you have a bag of balls is there. Your bag of items is there. 1, 2, 3, 4, 5. Now you want to pick two items. You want to pick two items. So simply close your eyes and put your hands in the bag and take that. Suppose when I do, there is a 2 is coming and 4 is coming. 2 is coming and that is one part. Data is one part. Next, again, what I need to do? Again, I need to pick one more data, right? I need to divide the observations, right? 1000 observations are how many parts? 4 parts. That means 4 times I need to do. 4 times I need to do. Each time, how many items I should bring? 250. So first time when I take my hand, I'm putting in the bag, I'm taking the 250 and put here like this. 250 are coming randomly. Then how many are left? Now the question is, you want to use 750 or again you want to throw the 250 inside the bag, again you want to pick the 250. The 2 points, right? 2 times of questions. Understood now? Now first time out of 1000 observations, we are picking 250 observations, 250 randomly. Okay. Now the question is, once 250 are gone, 250 are gone, how many left? 1000 minus 250, that means 750. Now the question is, will you use these 750 observations to pick next 250, next part, or will you like Will you pour again? First part 250 into bag. Will you pour 250 observations in bag again? Again, how many observations will be there? 1000 will be there. Again, you use this 1000 for next part. There are 2 points of questions, no? There are 2 questions are there. Understood the question? Can you please confirm the chat? Can you please confirm the chat? First time 1000 are there, you are picking 250. Now the question is next to 250 you need to pick. Will you 750 or this 250 again you put in the bag? Again randomly you will pick. Again randomly you will pick. That is the question. Based on this, tell me what is the mean by bootstrap aggregation. It is avoid overfitting, it is avoid variance, don't do all these things, but that is a use case. Okay, I am asking the definition. What is the meaning of bootstrap aggregation? With very good. Sample with replacement. Very, very famous word. Sample with replacement. Bootstrap aggregation meaning sample with replacement. Bootstrap aggregation. Sample with replacement. What is the meaning of sample with replacement? What is sample with replacement? Step 1. First, how many observations are there? First 1000 observations are there. Will pick 250 observations. How many parts you want to divide? That you can divide. You can divide randomly also 500 sometime, 100 sometime, like that also you can do. For the better analysis, we are taking that equal parts. Okay, first 1000 observations are there. We'll pick 250 observations randomly. And step 2, what step 2 will do? It is a with replacement. With replacement, what happen? Again the 250 you included in the bag again. You included in the bag. You included in the bag. Then how many observations will be there again? 1000 will be there. Again, how many are there? 1000 are there. And again, you will pick the 250 observations. Again, we'll pick 250 observations. Again, we'll pick 250 observations. And this process will repeat it. Exactly, exactly. Next, that is your observation is right. So first, 1000 observations are there. We'll pick 250 observations randomly. Again, we'll put 250 that included in the bag. Again, how many will be there? 1000 will be there. Again, we'll pick how many observations? 250. This is called bagging method. This is called which method? Interview question. Pakka interview question. Bagging is a very, very important for interview purpose. It's the bagging method. Now again, you will get a doubt. What is your query now again? First query. What is your first query? Don't think like that you are learning a subject. Think like that you are understanding something, reading a story. What is the first query? How to divide the observations. What is your answer? What is your answer? Bootstrap aggregation. Bootstrap aggregation. Bootstrap aggregation. What does it mean by bootstrap aggregation? Sample with replacement. Sample with replacement. Now, what is the second query? What is the second query? Now, Srikanth asked me, sir, if you do that, some observations will be repeated. No. If you do the same task, first 250 you are picked. In the 250, suppose Srikanth is there. Again you picked 250. In that also there might be a chance again Srikanth should come, no? Again that Srikanth should come, no? That is. You can pick individual data more than once. It is not a drawback, it is a advantage. Okay. Huh? Data? I didn't get, Avish. Tell me again. Same department. But these 250 observations will never exactly match. Will never exactly match with other 250. Other 250 will never exactly match. The scientific research is saying that when you do this, 67% of data will repeat it. 33% of data will never choose. Will never choose. This is saying that, what is they saying that 67% of data will be repeated, 33% of data never choose. Suppose I am there in the group, every time you will pick the randomly, but you are not never picking me. That possibility is there. And every time you can pick the Srikanth, that is possibility also there. So survey is saying that what? 67% of data will be repeated, 33% data will be never choose. ఎన్ని తీసుకుంటావు? అబ్జర్వేషన్ 1000 ఉంటాయి, 250 తీసుకుంటావు, ఒక పార్ట్ చేస్తావు, ఇంకో 250 తీసుకొని ఇంకో పార్ట్ చేస్తావు. అట్లా ఎన్ని పార్ట్స్ చేసుకుంటావు? ఎన్ని మోడల్స్ అప్లై చేస్తావు అన్ని మోడల్స్. సపోజ్ నువ్వు 3 మోడల్స్ అప్లై చేస్తే ఎన్ని పార్ట్స్ చేస్తావు? 3 అంతే. 250 250 250 3 టైమ్స్ చేసేసినావు అంతే. ఎన్ని మోడల్స్ అప్లై చేస్తాం అనేది డిపెండ్స్ అయి ఉంటుంది. Everyone understood this? 67% of data will be repeated, 33% of data will be never repeated. And suppose choosing, what is the probability? What is the probability? What is the probability to choose the observation? Tell me. What is the probability to choose the observation? Suppose there are n observations are there. How many observations are there? N observations are there. Then what is the probability of choose one observation? Very good. What is the probability of choose one observation? Probability of one observation is 1 by n. Correct? Probability of not choosing that observation. Probability of not choose that observation is equal to 1 minus 1 by n. Choosing observation is 1 by n. Not to choose that observation is 1 minus 1 by n. How many times this task you can repeat? Suppose I am repeating n times. How many times? N times. I am repeating n times. It will like this, ma. Very simple. Look at here. Choosing one observation is 1 by n. So not to choose that observation is nothing but what? 1 minus 1 by n. If you not understand, suppose n is equal 10 members are there. N is equal to how many members are there? 10 members are there. Choosing one person is what is the probability? 1 by 10. That means how much percentage is there? 0.1, which means how much percentage? 10 percentage. So not to choosing means how much percentage now? 90%. That means 1 minus, right? 1 minus 1 by n. So here each tuple has a probability being how much? 1 by d. Not being chosen, what is one? Suppose you are repeating d times. So 1 minus 1 by d whole power d, and you converted when d is large, the answer is 0.368. See, mathematically proved. Okay, I'm not saying like time pass, not state in a statement. It mathematically proved. Not to choose, and how many observations? 37% observations are not to choose. Every time, if you want to pick one observation, what is the probability of pick one observation is 67. And not to choose, how much percentage? 33. 33. So one observation is there. That probability to choose the observation is 63. Probability not to choose the observation is 37. This you need to remember, okay? 63 and 37. 63 and 37. Think like that. There are 10 observations are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 9, 10. Now out of this, only every time you can pick 1, 2, 3, 4, 5, 6, 7. Assume that. And 8th comma, 9th comma, 10, you are never choose this. You are not able to choose this. You are not able to choose this. Not able to choose this. That is our mathematics saying that. Not able to choose this. And now this data is nothing but out of bag data. What is the name of it called? Out of bag data. Very, very important interview question this is. Out of bag data. So the observations, how many observations? 33%, sorry, 37% observations are called OOB, out of bag data. Out of bag data. Out of bag data. And this data you can use as test data. You can use as test data. Because we are not using this for training, no? This data we are not using for training. So automatically 37% of data you can consider as a test data. So this will avoid overfitting of the model. This will avoid overfitting of the model. Overfitting of the model. So now again I am repeating, ma. The first question is coming. What is the first question? How to divide the observation. What is the answer? Bootstrap aggregation. What is the meaning of bootstrap aggregation? Sample with replacement. Sample with replacement. When you do that kind of thing, the scientific research is saying, what is saying? 67% data will be repeated. 33% data will be opposite, or what? 63 and 37. No? No, 63, 37. Sorry. 63, 37. And this is the proof. Choose observation is how much? 1 by n. Not to choose, how much is that? 1 minus 1 by n. You are doing how many times? N times. When you are doing n times, it is for the power of n. Automatically this answer will go to what? 37%. 37%. So now the conclusion is probability to choose observation is how much? 63. Not to choose observation is how much? 37. Assume that there are 10 observations are there. In that 7 observations are only you can choose. 8, 9, 10 you are not able to choose. And these observations are called which data? out of bag data. OOB, out of bag. Out of bag data. And this out of bag data used as which one now? Test data. Used as the test data. And this will avoid what? Overfitting. This will avoid the overfitting. That's the best use case of the bagging technique. That's the best use case of bagging technique. How can it avoid the overfitting? That's the next question. For the next question, how can it avoid the overfitting? How many models you want to do? Okay. Utkarsh, how many models you want to apply? How many models you want to apply? You want to apply. Suppose you want to apply 3 models. Then how many times you need to do? 3 times. 3 times. 1000 observations say 500 Lano 3 times. Take 500, again put 500, again take one more 500. Like that, how many times? 300. 3 times. That is the question answer. Next, how can it avoid the overfitting? First of all, what is meant by overfitting? How can it avoid overfitting? What by overfitting first? What you said? Low train error and high test error. Low train error and high test error. That means overfitting nothing but you just by heart the answer, simple way. What is in our Navy language? You are by hearting the question and answer. I am giving 5 questions and how many answers? 5 answers. Then you are by hearting. You went to the answers. In Telugu, there is a famous joke is there, no? Who is the Prime Minister of Pakistan? Appatlo Bhutto, Ippudu Musharraf. Telugu people knows that is. Okay. There is a one, in Telugu what happened? There is a one comedy is there. Okay. There 2 guys will go to interviews. 2 guys will go to interview. First person pays the question. Okay. First person pays the question. Who is PM of Pakistan? Okay. Then he's the heroine, I think. Heroine will say that long back, Bhutto. Now Musharraf. Okay. That is the old movie. That's why Musharraf is there. Okay. At the time. Now the second person, the person 2 asked to person 1 what they are asking the questions inside. Then what she will say that the question name is what? Who is Pakistan? And he asked the answer also. Okay, but he by-hearted only answers. Then the person 2 pays the interview like this question. Who is your father name? What is your father name? Then what is the answer? Long back it is Bhutto. Now it is Musharraf. So that is the overfitting. Understand? The overfitting is happened. The major thing of overfitting is happened. Overfitting is happened because of less data. Because of less data. Think like that. If I provided some amount of data, you can able to think. If I said only less data, you are not able to think. Think like that. Okay, less data, you will not able to understand the more patterns. The data is less, you might be overfit. So generally a data is there, you know that the data is divided into train part and test part. So then what happened? The data is divided into equal part, but in this bagging technique, whatever you are choosing, whatever you are choosing, automatically it become which data? Train data. Again, you are not dividing that. Again, what happened? You are not dividing that. So that's why amount of data is there for you to train the model. Whatever you choose the data, whatever you're choosing, that is become what automatically? Train data. So that data you are not dividing into again to some other parts. Automatically now this data will be huge. It is enough. This data is enough to train model. Enough to train model. Because here what happened? You divided data into some parts. Train and test. But here whatever you choose the data, you are considered as what? Which data? Train data itself. You are not dividing that again into some multiple parts. Understood the advantage? Whenever you are picking the 250 observations, originally what you will do? Originally, you will divide to two parts, train and test. But in this method, you are not doing that. You are directly taking this as which data? Train data. So you have a amount of data is there for to train the model. So generally model overfit happened because of not able to understand the patterns. You are simply by hearting. Why the chance of by hearting is coming? Because less information. Because of the less information. If less information is there, he will not able to think more. If you provide the more information, he can start things. He can start the thing. That's why whenever you want to discuss, you need more information means you want to analyze the patterns. You want to analyze the pattern. Always remember, modal overfit is happened. Modal overfit happened. One of the main reason is called less data. Less data. Modal overfit happened. One of the main reason is what? Less data. If less data is there, we'll try to increase the data. Try to increase the data. One of the technique is called data augmentation. What the technique is called? Data augmentation. So data augmentation is like this. Suppose you are doing a image analytics. You have very less images. Suppose a car is there like this. Okay. A car is there like this. You have only one less image is there. Now what happen? You do vertical. You will flip that vertically. And you will flip that 90 degrees, 180 degrees. Car is car, no? And that is called data augmentation. The best example you see here, data augmentation. Data augmentation. See this cat now. This is the cat original, but you are taking what this is? Is a normal. It is some 30 degrees, some 60 degrees, some only legs, only head. Like that, you are creating the data. From one sample, how many samples you are creating? Almost 10 samples you are creating. That means you are increasing the data. Tomorrow AI model will understand. Even though if you identify these legs also, AI model will think like that is a cat. That is understanding the more patterns. Understand the more patterns. Like that only, if you see in the Siri also now if you face detection, how it is taking, now it is asking put wear the cap, wear the mask and rotate like this. Everything is taking that. Even though if I put the mask also, my phone will be detected. That means understanding the more data. When you have a more data is there, you will generate the more patterns. Otherwise, what happen? It will by heart the model, by heart the output. So that is the thing. You are passing only this image. Think like that. You are passing this. Will it say is a cat? No, right? Not say the cat. You need to train with this also, right? Then only understand. By seeing the legs also, it is a cat. Where is this data? This data is not available. This data is not available. That means it can understand by showing this is a cat. But when you pass this data, it will not able to say that it is a cat. That means train error is low, test error is what happened? That is called overfitting. That is called, why the model is overfitted? Because you did not provided these kind of images because you don't have the data. You don't have the data, so I'm not able to understand only by seeing the legs. If I want to understand by seeing the legs, provide me that such kind of a data to me. Then I will learn the patterns. Then I will learn the pattern. That's why you are making from one cat to these kind of many things. Even though the head is not there, by seeing this, what you need to say? Cat. So that is called more data, more patterns. More patterns, model performance is good. Model performance is, understand the real-time scenario? Can you please confirm the chat? Understand? Can you please confirm the chat? So giving the more data will avoid the overfit. That's why you have read bagging will avoid the overfit. Correct? Bagging avoids the overfit. Automatically test data is forming automatically. And that is called out of bag data. Out of bag data. Bag data. So again, I'm repeating ma. First step. What is the first step? Bagging is one of the ensemble method. Bagging is one of the ensemble method. Bagging means bootstrap aggregation. Bootstrap aggregation. So bootstrap aggregation means what that meaning is called? Sample with replacement. The sample with replacement permutation combination be done in intermediate mathematics, right? Sample with replacement. When you do this kind of thing, when you do this, 63% of data will be choose. Remaining 37% data will never choose. So this 37% of data is called out of bag data, OOB. Out of bag data. This OOB data consider as test data. So to train model, we have amount of data is there. That means more than 50% of data is available with you. More than 50% data will be available. We have more than 50% of data. That is how much? 63. So this will avoid overfitting. So 63% of data consider as train data. With this train data, you will get which error? Train error. 37% of data consider as test data, and this is nothing but a test error. And here, especially in this case, the test error also called as out of bag error. OOB error. This question they asked me in the Deloitte interview. What is meant by OOB error? Out of bag error. It's a simple common sense. So we are taking that OOB is nothing but that is the test data. Test error, it is called OOB error. Out of bag error. So this is about bagging. Will you able to say in the interview these 10 steps? Bagging means, bagging is one of the ensemble method. Bagging means bootstrap aggregation. Bootstrap aggregation means sample with replacement. That means how much data percent will choose? 63. How many are not to choose? 37. So 63 consider as what? Train data. 37 consider as what? And that is called out of bag data. So we have a amount of data is there to train the model. What is the use case now here? Avoid the overfitting. And this out of bag data, out of bag error, and avoid the overfitting, the reason, everything they can might be asked in the interview. Understood? Can you please confirm the chat? Very good. Now, the example of bagging. The best example of bagging model is random forest. What is the best example? Random forest is the model, that is the example for bagging technique. First of all, bagging is which method? Ensemble. In that bagging, what is the best example? Random forest. Ensemble means group of models, group of different models. Bagging is one type of ensemble method. Ensemble method. The example of bagging is called what? Random forest. Forest में क्या होता? Trees होता. So now instead of group of different models, instead of taking deep group of different models, we'll take that consider as group of decision trees. Group of decision trees is nothing but a random forest. Now every data you are picking, you will not apply the logistic regression, KN and Navi Bayes. On every data, you will apply decision tree only. Are you getting what I'm saying is? Every data you are picking, suppose 3 parts of data you are picking. You are picking the 3 dots or 3 data. Now you divide to data into 3 parts. Okay. Data D1 is coming, data D2 is coming, and data D3 is coming. Ensemble means what? Applying that logistic regression, KNN, Navi Bayes. But random forest means every data will apply which model? Decision tree only. Every data will apply which model? Decision tree. Decision tree. Then this is nothing but a forest. It's called random forest. Simple. Ensemble means multiple models. Random forest means multiple models, not only one model on multiple data. What is the model? Random forest. That is the random forest. Why we are applying the different models? To get the big conclusion, no? This is one good question. Why we are applying the different models in different parts means what happen? Every model is a unique. Every model is unique. So unique pattern learning. Unique pattern learning. So instead of applying one model entire data set, if you divide the data and apply different model, then your judgment will be much more worth. Judgment, the solution will be robust. Solution will be robust. Think like that there's a committee of members is there and there is only one person is there. Judgment will come from where? One person or committee? Committee, no? How can one person will give the good judgment? Always committee will give that good judgment. You have a problem is there. You'll talk to with family members, then you'll get a good judgment, no? Same like that. Committee always give that Good judgment. That's fine. Supreme Court bench, why, how many will be there? 4 or 5 members will be there. A big solution they want to give and a problem, they will discuss and they will give, no? So that is the meaning of that. So every model is unique and you are training that 67% of data is repeating, right? If data is repeating, so some observations are common, some observations are not common. Some observations are common, some observations are not common. So the pattern learning are much more important at the time, the pattern learning. So you think like this now. So again, same thing, this data is there. Now you drawn one data, D1. You draw one data. In this data, what happened? The output is there, the Shah Rukh Khan is there, output is the Salman Khan is there. Okay. In this D2, maybe you got only Shah Rukh Khan as an observation. In the D3, maybe you got Salman Khan observations. That might be possible. But this data has the specific, now both are included. Both are included. And this data is only Shah Rukh Khan included. And this data only Salman Khan included. Imagine that you are applying only one model, that entire data is included only Shah Rukh Khan. That become a Bakwas model, no? Then that means the pattern learning, same data is taking here some of the data. Some data will be common. Some data will be what happened? Common. And some data will be different. And pakka it will generate a robust solution. The solution will be good. The solution will be good because same question I am giving to suppose Avesh and same question I am going to Srikanth. Now a different question is going to Srikanth, another different question going to Avesh. Okay. That means imagine the best example, Indian cricket team. Indian cricket team. First members are what? Batsmen. Last members are what? Bowlers. Middle numbers are what? It is a bagging. It is an ensemble. Now think like that all our batters are there. What happened? Think like that all our bowlers are there. Understood? That is the meaning. So always combination of models will give that better solution. You can tell this perfect example in the interview. Indian cricket team. So we divided batsmen, bowlers and all-rounder. Everyone has a specific skill. Everyone has a specific skill and that skill we will use in the outcome. And one more last thing is there. Now tell me what is the bullet points here? What is the first point? What is the example of bagging? Bagging example is random forest. So random forest means we'll apply different data on, we'll apply decision tree. Decision tree is the only algorithm, on different data sets. But while you applying the decision tree, there is a problem is there. If you use same variables, if you use same variables to calculate the root node, to calculate the root node, there might be a chance, only one variable come as root node for all the decision trees. Correct? Now think like that there is a age is there and the gender is there and the income is there. Now you are using these three variables, first decision tree. Maybe who will come the root node? Gender. Again, these three you are given the second decision tree. This time also gender might come. You can't deny that. This time also what came? Gender will come. Every time, every decision tree gender is there, then your output will be what happen? Biased. Your output will what happen? Biased. Every state only one party is in the ruling. Then what happen? Total India. What happen? Every state is in BJP only there. Huh? What happened then? That is the problem. No, understood now? There might be a chance root node might be a same. Because in decision tree, what is the main goal? Decision tree, finding the root node. Finding the root node. You are dividing the data. Okay, that is fine. You are dividing the data. But every data as the variables are same, no? Think like that. This is the data. This is the data. Now age is there, gender is there, income is there. You are dividing the data means all three observations are coming or not? All the three observations will come. You are dividing the data means all the three variables observations will come. That means every time you are choosing a small set of data having the same variables, yes or no? Age will be there, gender will be there, income will be there. Again, you are dividing the data. Again, same columns will be there. Age will be there, gender will be there, income will be there. Whenever you calculate the entropy or Gini, then this time age is coming. This time also might be who will come? Age will come. So the root node might be same. The root node might be same. So this is very, very important now. And this will leads bias. This will lead to bias. The output might be bias. To avoid this, generally, in ensemble method, we'll pick observations randomly. Correct? Saurav? Generally, what we will do? Ensemble method, we'll pick the observations randomly. But in random forest, we'll pick not only observations, but also variables also. Variables. So when you divide the data, you will not only divide the data randomly, you will choose either age and income together or age and gender together. So every time what happens, all the variables will not go. I will explain the diagrammatically. Look at this. Look at this. Now age is there, gender is there, income is there. Now there are 10 observations are there. How many observations are there? 10 observations there. 1 to 10. Now to create one decision tree, you will pick, suppose assume that 6 observations. How many observations? 6 observation. The 6 observation, not you are taking all the variables. You are taking also this also randomly you are picking. This also you are picking randomly. This time only age and gender will come. 6 observation total will come. But how many columns will come? 2 columns. Again, you are creating one more decision tree. You are taking one more 6 observations. And this time who will come? Gender and income will come. So there might be a chance the root nodes are not be same now. Root nodes are not be same. Root nodes also will be different. So that is the random forest you need to explain. This one you need to explain in the interview. Generally, an ensemble method will pick observations randomly, but in random forest, what we'll do? Not only observations, we'll pick the variables also. Every time we'll pick root p variables. Suppose p is equal to total number of variables, total number of predictors. So we'll pick root over p. We'll pick root over p. We'll pick root over P. Root over P. Suppose there are P is equal to 100 variables are there. P equal to 100 variables. So every time you will pick how much data? How much data will pick? Root of 100. Root of 100, you will pick only 10 variables data. 10 variables data. 10 variables data only will pick every time. So this is will reduce the to avoid the bias. So this is a very important in the random forest. Root P, what is the use of random forest? Random forest is first which method? A bagging example. In that all the models are what models? Decision trees. But what is the drawback when you apply all the variables? Root node might be same. To avoid that, what you will do? Not only select the samples, but also select the variables. How to select the variables? Root P. Random forest is the best model. If you want to apply decision tree, instead of apply decision tree, we'll apply the random forest. Again, concept is same. Gini, entropy, that concept is same. Only this is the concept we'll add. This 9 concepts will be add, 9 steps. Best example is random forest. We'll apply decision tree on the each algorithm and each data. So decision tree important use case is calculate the root node. If you provide all the variables, there might be a chance only one variable will become as a root node. This leads to bias. To avoid that, we'll not only pick the observations randomly, we'll also select the observations, we'll also select the variables. That concept you need to explain in the random forest. Again, the mathematics is same. What is the mathematics? Entropy, Gini. So this is about the random forest. So this is very important concept today. And say what is the meaning of ensemble method? What is the meaning of bagging? What is bootstrap aggregation? How much percent of data will covered? How it will avoid the overfit? And what is the best example of bagging? That is called random forest. Understood random forest? Can you please confirm the chat? Please confirm the chat. Utkarsh is good. Nagarani is good. Very good. Yeah, that's all. Tomorrow class is there as usual time. Thank you. Thank you so much. See you tomorrow.